So this is preparation for exercise 9.5, the circle. I'm going to do it in two parts. The first part is finding the equation of tangents. Loads of core geometry in this stuff. Anyway, the first case, now throughout all this stuff, every time you're given the equation of a circle, anywhere, write down the point, write down the center and write down the radius. So in the first case here, and I've just taken examples from your textbooks, just makes it easier for me to do it. So anyway, point on a circle, find the equation of the tangent at that point. Step one is draw a diagram as neatly as you can. So what we're going to actually do here is steps here. You find the slope of the radius because you have the point of contact and you have the center. That allows you to find the slope of the radius. The tangent is going to be perpendicular to the radius, so therefore you can work out what the slope of the tangent is. So now you have the slope of the tangent and you also have a point on the tangent, which is the point of contact with the circle, and use the equation of a line formula. So here we can, from this equation here, we can work out the center. We use the center and the point of contact to work out the slope of the radius. We get the perpendicular slope, turn -4 over 3 upside down and change the sign. And then we go and find the equation of the tangent. Nice question. Next one is more challenging. What happens if there's a point outside the circle? If there's a point outside the circle and you're trying to find the equations of the tangents, first thing you do is write down the center and the radius length of the given circle. You have to let the slope of your two tangents be m because you don't know what it is. And then we find the equation. We go ahead and find the equation of a line passing through the given point outside the circle. That's in this case 1, 0 of slope m. And in general, it works out something like this here. You've got your equation of a line formula. The slope is m and the point is 1, 0. Fill in that information. You get this equation here, mx minus y minus m equals 0. The perpendicular distance from the center to that line is equal to the radius. So the distance from 6, 5 to that line equals square root of 10. And you fill in that perpendicular distance of a point to a line formula. Simplify as much as you can. Bring across the square root of m squared plus 1. Square both sides and you end up with a quadratic and you solve it and you get your two slopes. And then you have to go back in and sub those two slopes back into your equation of a line formula and you end up with your two equations of the tangents. That's a fairly sophisticated question. It is one I would practice and just get right because it could come up as a 15 or 20 mark question. And this one here, one really important thing here is this bit here. You're talking about parallel lines. We'll hit on that now in a second. So for the question, find the equations of the tangent to this circle here. Again, we can write down the center and the radius straight away, which are parallel to this line here. So first thing you do is write down the center, write down the radius. -3 minus 1. Take the 6, divide it by 2, change the sign. That would be the x value of the center. Same here, you get -1. Radius length form is in your maths tables. Now for this next part here, the equation of any line parallel to 3x plus 4y plus 10 will be of the form 3x plus 4y plus c equals 0. Now, again, this particular line here will be a radius length away from the center if it's going to be a tangent. So we use our perpendicular distance from a point to a line formula again. And you fill that in there. ax plus by plus c over the square root of a squared plus b squared. And it comes all the way down here. And we're down to modular equations again here. c minus 13. The number in here must either be equal to 25 or minus 25 if its modulus is 25. So you end up with 38 and minus 12. And then you go back and fill in your values for c, and that's that. So the relevant questions, let's take this up on Edmodo, are questions 1, 2, 3, 8, and 9 from that exercise on page 310.